So we've made it. This is the last video. This is the last whisk of this material before the next test. Our next test is going to be right before Thanksgiving. So this is going to be about organic chemistry. And organic chemistry is different than what we've talked about so far in chemistry because the naming rules is a little different. Organic chemistry in college is a very hard class, but don't worry, we'll just do the easy stuff. So what is organic chemistry? Well, organic chemistry is the chemistry of compounds that have carbon in them. There are a few exceptions, most notably carbon dioxide and carbon monoxide. In fact, anything that's a carbonate or an oxide as a polyatomic ion will not technically be organic chemistry. Organic chemistry, when you hear the word organic, you think, natural and green and growing things, and it's because they used to think that anything that had carbon in it had to come from living things, that it could not be made artificially. We since know better, but still, organic chemistry is the chemistry of life in many cases. Sugars and fats and proteins and nucleic acids, these are all organic compounds. What makes carbon so special? Well, carbon can bind to many things and make many shapes. Why is that? And if you answered because carbon forms four covalent bonds, you are correct. It has four valence electrons, which means it needs four more, which means it's going to need to do a lot of bonding. I said we're only going to do the easy organic chemistry, so we're going to stick with hydrocarbons. What makes hydrocarbons easy? They only have carbon and hydrogen, no other elements. So, first of all, important thing in naming hydrocarbons is the prefix. These are slightly different than the prefixes that we saw earlier for naming covalent compounds. One is meth. Yeah, enjoy your laugh while you can. Two is eth, three is prop, four is bute, five is pent, hex, hept, oct, non, and dec. Now, what is it going to end with? What is the suffix going to be? That's going to depend. And these prefixes are referring to the number of carbons here. So 1, 2, 3, 4, 5. It's going to take what prefix? Pent. So as far as the suffix, again, that's going to depend on whether it's an alkane, an alkene, or an alkyne, and that's going to depend on what sort of bonds are present. Alkanes only have single bonds, no double bonds, no triple bonds. Their formula is going to be a certain number of carbons, and the number of hydrogens will be 2 times the number of those carbons plus 2 more. So C8 H18 would be octane. Alkanes take an ane ending. Alkenes have at least one double bond. Alkenes are going to take an ene ending. And its formula is going to be a certain number of carbons and the number of hydrogens, 2 times that number of carbons. Less hydrogens because you've taken up some of those hydrogens that can fit by putting in the double bond. And this is if there's only one double bond. If there's more than one double bond, this number will go down. We will only work with it as if there is only one double bond ever in these, just to make it simple. Alkynes, alkynes. These are going to have at least one triple bond, and they will take the ine ending. The formula, a certain number of carbons, that's what the N stands for. Number of hydrogens will be 2 times that minus 2. If there's only one triple bond, and for our purposes, there will only ever be one triple bond. You don't need to memorize these things. You can always draw it out, remember. But if you can remember these nice simple rules, that will make it easier. This you may recognize here as a propane bottle. That's going to be an alkane, right? And prop, how many carbons is that going to have? Well, if you go back to the last slide, you will see that that is 3 carbons. I just did that for you. Okay, well, try to name this one. So right, we can see right away that that's going to be an alkene, and since it's got 2 carbons, that's ethene. And here, C2H2. We can see that's an alkyne, and so that's going to be ethyne. Okay, but it doesn't stop there. It gets a little bit more tricky because as these chains start getting longer and longer, we can have something that has the same formula but a different shape. Now these shapes look fairly similar, but if you take a look, this one has a branch off to this side. It all depends on how the carbons are connected, whether it's a straight chain versus a branch chain. The easiest way to tell is if you can trace a line through all the carbons without doubling back. So in this one, we can go 1, 2, 3, 4, 5, 6, 7 through them all without doubling back, but this one, 1, 2, 3, 4, 5, 6, and then we would have to go back for the 7th. Same number of carbons, same number of hydrogens, but it is a different isomer. The formula would be exactly the same, but they look different, and since they look different, they have different properties, different boiling points, different melting points. All of that is slightly different. Anytime we have a branch group like this, it's called an alkyl group. So, the structure on the right, see if you can name it real quick. And what we have is 1, 2, 3, 4, 5, 6, 7. So the prefix for 7 is hept, and it's all single bonds, so it's heptane. Heptane should be nice and simple. It will require some practice. Don't worry if you don't have it yet. Whereas the structure on the left is 3-methylhexane. There's no way you should know that yet. Don't worry about it, because that naming seems very counterintuitive. But let's learn how we would name that, starting on the next slide. Okay, naming hydrocarbons. Now for branched hydrocarbons, a little bit more confusing. First of all, we'll name the parent chain. How do you know if it's the parent chain? It's the longest one. So we can go 1, 2, 3, 4, 5. Okay. We could also count 1, 2, 3, 4, 5. Remember, it doesn't count as a branch unless it doubles back. Even if it bends, it's not necessarily a branch. So we would say 1, 2, 3, 4, 5. The parent chain is pentane. Name the alkyl groups. Well, if we've got 5 here, then we've got an alkyl group off here. How many carbons are in it? 1. So we said meth is the prefix for that. And since it's an alkyl group, this will be methyl. Il, not methane. Okay, then we'll number the carbon atoms on the parent chain. 1, 2, 3, 4, 5. You could say, well, why don't we do 1, 2, 3, 4, 5? You're always going to start from the side that's going to have this alkyl group first. Whatever number will make this on a lower number carbon. So 1, 2, 3, 4, 5. Now we'll use the position numbers. Which carbon is this methyl attached to? That's carbon 1, 2, 3, 4, 5. So carbon 2. Methyl group is at position 2. And then we'll add in some punctuation. Put a hyphen between the position and the alkyl group, commas if there is more than one position number. What if we had another methyl right here? So this becomes 2-methyl, I forgot the L right there, there should be an L, 2-methyl pentane. 2-methyl pentane. We will practice this more in class, don't worry about it. Marshmallows again, you guys like the marshmallows? I'll buy another bag, it'll be great. Okay, just one more thing we need to talk about naming, because what if there's a double or triple bond? It could be here, or it could be here, or maybe it could even be here. How do we know? Well, we're going to follow the same naming rules for alkenes and alkynes. So first of all, we'll name the parent chain. How many carbons in the parent chain? You should count 5. So this is going to be pent. But since there's a double bond, since this is an alkene, it's not going to be pentane. It's going to be pentene. Okay, we'll name the alkyl groups if they're present. I don't see any. This isn't a branch chain. I can go 1, 2, 3, 4, 5 straight through them without doubling back. Number the parent chain. Notice I went 1, 2, 3, 4, 5, not 1, 2, 3, 4, 5. Why do you think that is? Same reason as before. So we're going to start from the side nearest the double bond. Just like before, we started from the side that was nearest that alkyl group. Then use the position number. For a double bond, we're going to use the first carbon that it's attached to, which is going to be carbon number 2, right? The double bond is on the second carbon. We'll add punctuation just the same as before. See if you can get the name. So this is going to be 2-pentene because this double bond is on the second carbon and it's pentene. 2-pentene. That's basically all there is to it. Of course, it can get much more complicated, and the bigger and bigger these chains we make, the more chances that there will be these structural isomers. In fact, you can get to numbers so big that there's millions of different isomers and we could never possibly make them all. But these are the basic rules. This organic chemistry is actually in chapter 22 of the book. So I would recommend that you go to chapter 22 and try a few of these simple ones, particularly on page 714 and on page, let's see here, page 722 there's some practice. On page 726 there's some practice. Practice some of the easier ones. There's no need to really work on the harder ones for now. We're going to keep it nice and easy because we've already learned how to name covalent and ionic and polyatomic ions. We've learned how to draw Lewis structures. We've learned how to do three-dimensional structures. There's been a lot in this chapter already. So we're not going to go too in-depth to organic chemistry, but it is important that we know how to name them. That's it. Don't forget to do the whisk.